All right, can everybody hear me okay? Sounds like it now, right? Okay, we got that fixed up. All right, so it's a couple minutes after 2:05. I'll start in just a second. I see a couple of folks trickling in, and then we'll get going. We have a fairly small crowd, so feel free to interrupt me whenever you want, ask a question. I'm happy to go dive more into something or less into something as we go. We have a small crowd. We might as well make use of that fact. So feel free to interrupt me as we go. I'll just get started. Looks like we've got the last couple folks trickling in. I've never done this in a presentation before, but the first thing is that my name isn't Matt Winkler. It's like an airplane. You get there and you realize the flight you're on is actually operated by somebody else. It's one of those. It was a talk by Matt Winkler. You bought the ticket for Matt Winkler. You're getting operated by Mike Flasco. Matt, honestly though, Matt says sorry for not being here. A death in the family took him away, so you're stuck with me. Short story though, Matt and I work on the same team at Microsoft. Specifically, we work in our big data platform team. So we've been doing the same things. He would argue he does it better, but I'll let you guys be the judge if you ever see him present later. So short story, with this presentation, we were hoping to do a couple of things. One was just share our thought process, our journey, what we've been doing with Hadoop development tools, what we're building, why we're building it, how we think about the Hadoop community. About 16 or so months ago, we started building a platform at Microsoft that was completely built upon Hadoop, specifically Hortonworks Data Platform. And one of the first things we had to go do was build out kind of developer tools around it. So we looked at what's already there, what do kind of developers coming from a Microsoft background, what languages do they use, what are they used to, what are some developers coming from a web background used to, what does Hadoop already have that's awesome, how can we help improve in some of the other ways. And so there's a couple slides at the start of this session that basically just show kind of what we were looking at, how we started to think, and then it just gets into what are we building, why are we building it. Really just the idea being start a dialogue with the community around some of the things we're building, useful, not useful, do something else, keep doing that, that kind of thing. So the first thing that Matt and I had to do was kind of, as we started down the Hadoop journey, was look at, okay, what exactly constitutes a Hadoop developer? What's the state of the art? What can we go build? And we started to think about the community as a whole as kind of a set of layers that you get in almost any large software stack as you go. And the first thing we looked at was just core Hadoop. What was already there? What were all the projects that were there? Hive, Pig, MapReduce, et cetera. What was the state of the art of the tools there? What were people used to? What were some of the gaps? What could we do? One of the things we noticed right out of the gate with Hadoop is that a lot of people were used to Hadoop development where they were physically near or I'll say virtually near their cluster. What I mean by that is they were sitting there almost at a command line over top of the cluster, often as a very elevated user, when sometimes all the person wanted to do was author MapReduce or author Hive. And so they're sitting there almost as an admin user at the command line partying on the cluster, which, as you know, when it starts to get out into kind of an enterprise setting, when some of these clusters start to power kind of mission critical analysis, et cetera, that type of kind of coupling of things doesn't really start to work. And so one of the things we started to look at was the REST layer in Hadoop. Partnered with Hortonworks and started to add in some thinking and development around the REST layer, and then also talk about some of the things that we're doing and in addition to that to really make Hadoop a little more decoupled from the standpoint of I can be a Hadoop administrator, or I can be a Hadoop user, meaning author, Hive, and Pig, or I could be a Hadoop DevOps kind of guy. And not everybody necessarily has to be super user or in front of a console or command line console to interact with Hadoop. So the consistent REST APIs was a lot of our thinking there. Breadth clients, one of the things we quickly realized was that in talking to a lot of our customers, and we do a lot of things kind of worldwide, talking to various folks that are trying to adopt big data, and one of the things we heard a lot was, I have a need, I see a need, but my development force isn't trained on Java. What do I do? And so one of the things we started looking at is, well, how can we extend Hadoop development to the language of choice for those individuals So adopting Hadoop isn't necessarily a language choice, it's a platform choice, but you get to use the language that you're most comfortable with or you've trained your workforce in, or whatever it might be. So we'll talk about some of the things we've been doing to extend development to other languages. And some things that have gone well, some things that haven't. But the moral of our story is thin client layers that make you feel makes it feel natural in your language, but not a ton of machinery that's kind of between you and Hadoop. Then you just spend time learning somebody else's SDKs and libraries, and it's just reinventing the same problem. And then the last bit is what I've dubbed tooling. This is a very broad space. But the thing I'm going to focus on today specifically is around operations, and especially dev operations. One of the things we heard a lot when we talked to people, especially those getting started with Hadoop, they'd get excited about it, they'd see a need for it, and then getting started out of the gate was tough sometimes. It was, how do I get a cluster that I can start playing with, maybe to do a proof of concept? Or as a developer, there's some issue going on in my production cluster. How can I step through that without being kind of live connected to the production cluster, because I may not want to interfere with that? And so how do we provide the right tools and debugging experiences so that you can take all of the techniques that have worked well in many other areas and start to apply them in the Hadoop area? So that's the kind of how we started to think about things. The first dichotomy we hit was that we had to look at, do we invest significantly in helping people author jobs, MapReduce, HivePig, et cetera? This is more of a question. Or do we start with kind of solution integration things like, how easy can I spin up a cluster? How easy can I get kind of local debugging? How easy can I make it so that interacting with a cluster or making my particular MapReduce job part of an overall workflow is simple? And so these are two big areas of feedback we got when we started kind of really diving in with our Hadoop platform. And so we started to invest along each of these areas. I'm going to just kind of push through. You're getting the operated by Mike version now, so I'm going to skip Matt's commentary here. So, you know, he had some stuff to say. I'm sure it was awesome. Not exactly sure what he would have said there. So we'll do the jump over instead of me trying to pretend. But the short of it is, with those layers, we've chosen to invest in 4 places. Right now, what we've called existing ecosystem, that really just means what we traditionally think of as in the Hadoop ecosystem, already there, or areas that are evolving around it. We'll talk about some of the things we've done there, especially around cluster creation and kind of getting started with Hadoop and debugging. JavaScript and .NET, these are 2 of the things we've been working on to extend Hadoop to more developers. Our thinking is that it's better if we have more folks who can develop on Hadoop. That's going to create more innovation in Hadoop. It means that you don't have to make a language choice in terms of adopting Hadoop. You can adopt, you can use the skill set you're after, and you can get going. So we'll talk about some of the stuff we've been doing lately in JavaScript. Some things have worked for us, some things haven't there. And then some of the stuff we've been doing in .NET, which is one of the platforms that we've had kind of traditionally in Microsoft for a while. And then lastly, some of the things we've been working on for operations, and especially dev operations, where you want to get going with Hadoop, you want to manage a cluster, and we've really started to focus in on Hadoop in the cloud and some of the unique opportunities that that can present. So we'll talk about some of the things that we're doing there. So without too much more kind of setup, basically the way that the talk is structured the rest of the way out is we'll go into each of these 4 areas in turn, ecosystem, JavaScript, .NET, DevOps, look at some of the stuff we've built kind of as a demonstration, and I'll provide the commentary along the way in terms of why we're doing this, what's worked well, what hasn't. Hopefully it fosters some ideas for all of you, causes some feedback. Maybe we can collaborate on some of these or other projects to make the overall Hadoop development experience better as it goes. So that's kind of the goal of the talk for us. So existing ecosystem, let's dive right in. What we've been doing, so this might sound like an obvious one, I got to say it, is that what we were doing from the very beginning was, how do we help developers, especially being from Microsoft, will we make Hadoop run well on Windows? So did that one first, check, kind of obvious. But honestly, you've seen contribution. We've done a set of contributions with Hortonworks and independently to really make Hadoop run really, really well in Windows. So again, as a developer, you have these options on where you want to run Hadoop. That's the first point, not a big part of this talk. The next point, though, around the existing ecosystem, one of the things we heard as we went around and asked customers, hey, what's your big data solution look like? Where are you at in that life cycle? Are you trying to spin something up? Are you an evolved customer? Where are you? Every time we got the conversation that started with, we see the potential for big data, we're trying to get started, and we're planning a POC. And then we get in this conversation of a lot of planning, and they'd have to like procure some hardware and do a bunch of stuff. And so one of the things we said is, look, I think one of the best places we could start is in streamlining deployment of clusters and really streamlining the ability as a developer to get up and going and try something quickly. So we invested there out of the gate and did two things. One was the ability to create a standalone Hadoop cluster that runs really well on your laptop. So as a developer, each time you're out, at a big data camp or wherever you might be, and you see something new and interesting in the community, you can go, enlist, pick that up, bring it back, and give it a try. And ideally do that really fast. So what we did, we started out with this on Windows. I'm going to jump out here and show you. There's something in Windows called the Web Platform Installer. You don't have to spend too much time on understanding what this is. It's just an easy way for us to integrate an installation experience. But we have a product called HD Insight. Just for the sake of this talk, all you have to know is HD Insight is built holistically on Hortonworks Data Platform, or Apache Hadoop for that matter. And so what we did is, as our own developers were getting up to speed on Hadoop and building out HD Insight, they wanted an environment so that they could build out, MapReduce, try Hive, try Pig, get up to speed. We integrated with what we call our Web Platform Installer, and the experience here is that I've already installed it, but in one click, we start up a Hadoop installation. We take you through a wizard that's a few more clicks, and what you end up with is, I'm going to take you to my messy desktop for a second, with a few icons on your desktop. One of them is your typical Hadoop command prompt. And so in this case, I think I'm even running a local build, which you can see I am. But at this point, what I've got running on my laptop is a full Hadoop cluster. It's a pseudo-distributed cluster, so everything's running as its own process. So you get that experience of task tracker, job tracker, all communicating as they would be. But as a developer, I've got everything running locally. And so as I want to try out new things, I can very quickly try them out. I don't have to ask anybody to set me up something, procure me space, anything like that. So to show you it, you've got kind of the full tracking pages that you're used to. And then on top of that, we add some local dashboards. One, it says local HDFS. One says mflasco. We give you kind of a simple web-based UI, and you can bind it to your developer cluster running on your laptop, or our cloud service that also runs Hadoop. But for the sake of the conversation, we'll look at local. And if I click on local, it says my Hadoop cluster is running. I'll talk about this in a little bit. We've got a little interactive JavaScript pane that we've been playing with. We've got some getting started content to get you going. And then to get people really going quickly out of the gate, if they go online, they pick up kind of a simple MapReduce program, you can just type the name of a job, point at the class file, point at the jar, specify the class file, point at the jar, any job configuration, and click Submit Job. And so the idea is that as a developer, it's super simple to get yourself a cluster, have a fully functioning Hadoop cluster. If you're part of the Hadoop community, you've got the whole thing running. But if you're new to Hadoop, you've got some simple web UI to get going. So that's the first bit that we looked at. The second bit was we went and integrated HDP into our cloud platform, so that, again, if you're getting started with Hadoop or you want to try something at scale, it's not much harder than that simple installation to get yourself a cluster. You can go to, let me do it live. Let's see how well this guy holds up for us. It's already not holding up overly well. Let's try this guy really quick. Great. OK. So if you go to windowsazure.com, that's just the URL of our cloud platform. Hopefully this thing will come up. Is anybody else having network difficulties? I'll bail here in a second if this doesn't fly for us. Not so much? I guess that's what happens when you change mid-flight. So let me try and get rid of this guy real quick and switch back the network. Sorry about that. I apologize. Get rid of this guy as fast as we can. OK. And let's see if I can get back on. Is anybody having luck with Hadoop Summit or Hadoop Summit G right now? Hadoop Summit? Yeah. All right. So let's try this guy one more time. Give it a second. Come on. All right. Did this guy come up as well? All right. Sorry about that. All right. Little hiccup, but now it looks like we got a connection again. Awesome. Come on. All right, there we go. So what I was trying to do is get into this screen, which is me logged into our cloud service. Don't worry too much about the details. What I just want to show you is some of the work we were doing to try and make it really simple to procure a cluster, specifically at scale. So if you're trying to do a proof of concept as a developer, getting up to speed, being able to spin up an Apache Hadoop cluster that's kind of a true Apache Hadoop cluster without any other FUD fairly quickly. And so if you go to windowsazure.com, you can click New, Data Services, HD Insight, which is just our name for our Hadoop-based service. Say Quick Create. You can give it a name of a cluster. So let's call it Hadoop Summit 2. I can select how many nodes I want in my cluster. It could be like 4, 30, 40, whatever you want. Give a password. And in this case, you select a storage account. This is just like think of it as a big disk in the sky. And I click Go. And what it's doing is it's submitting this job, and it's going to go procure me a cluster. It takes about 15 minutes to spin you up a cluster pretty much anywhere in the world that you want it, up to about 40 nodes. And so as a developer, if you're working through a tutorial and you go, I'd like to try that out, you can come and in a few clicks have yourself an HDP cluster running in the cloud pretty simply. I'll show you what one looks like to log into. But short story is if you want direct access to every node of the cluster, you can do that as well. And so we'll spin up the fully functioning cluster. It'll be running Hive, Pig, MapReduce. You can also connect to each of the nodes and look at them directly if you'd like, if you're that inclined with Hadoop. So from a developer's perspective, it's pretty powerful to get a Hadoop cluster in front of you very quickly. So let me jump back into the slides as that's spinning up, and we'll come back to it in a second. So that was our first thing, as we looked at it and we said, look, getting a cluster is too hard. That's hurting developers joining this ecosystem. This is the first thing we went and did as kind of trying to help. The next thing was trying to extend Hadoop development to more languages. One of the first ones we started with was .NET, but the ideas, I think, apply very well to other languages too. A couple of things we've done is, one, we haven't tried to just mimic what people were used to maybe in Java or in another language in .NET. Instead, we tried to take the concepts and paradigms of that language and then bring Hadoop into it. So as a .NET developer, everything should feel very natural to you. As a JavaScript developer, same thing. But one of the things I think that a lot of folks had wanted was, at least when we talked to them, was a simple debugging experience. Because as you're getting going as a developer, and you submit that job for the first time, and it might have errored out, and you've got some log files to go comb through to figure out what happened, it can be tough. And so ideally, you want to be able to step through this, and you want to be able to step through it pretty quickly before you get to the point of submitting your big job. So one of the things we looked at was a better debugging experience. But then also from a unit test perspective, as people are evolving their custom MapReduce jobs over time, you want to be able to isolate the various components of your solution and have them be unit testable so that as they evolve over time, as you're changing it with various data, you don't break prior assumptions of a past developer. So one of the things we did is we made a little framework for the .NET developer so that they could write MapReduce, run locally, run in memory for really fast debugging and stepping through, run locally against that standalone cluster that you might have installed on your laptop, or push the entire solution to the cloud. So let me show you what that looks like over here. So if you're not a .NET person, you're not a C# person, but you are a Java person, things should feel fairly familiar. The idea is not to, teach you .NET or C# or anything of that nature. The idea is just to show you some of the approaches we're taking. And so if you know what a class is, you know what an object is, you know what a namespace is, that's really all you need to know. But what you're looking at is a C# program. It's the simplest one. It's a main method. It gets invoked as soon as the program gets executed. And I've just written a method called run word count for unit testing. And so I'll show you what run word count for unit testing looks like, followed by run word count for on cluster. And the idea is that as you're building out your solution and you're writing your mappers and your reducers, you want to be able to unit test them quickly, make sure they don't break with time, but then easily deploy that same code to your production cluster. And so run word count for unit testing looks kind of like this guy. So let me expand this, and you can see how this goes. And so the first thing is I do a simple string array with my mock data. And this is just a bunch of string data that goes on. Some input, some more input I did, et cetera. So from a unit testing perspective, you could feed this data, this mock data, from wherever you want. We wrote a streaming unit class that you can point at a mapper function and a reducer function written in C#. This is where we have mimicked the Hadoop patterns and the MapReduce patterns directly in C#. You write a map function, a reduce function with all the same pre and post conditions of map and reduce. But you can say, run this thing and execute it, and we'll execute the entire thing in memory off of this mock input, so that from a unit test perspective, you can easily get the result, compare it to expected, and fail the unit test or succeed the unit test. The key thing is that we've encompassed everything in kind of your mapper class and your reducer class, so that I can run through and get the entire result. Now let me show you the equivalent running against like one of our cloud clusters to show you how, if you passed your unit tests, you'd push it up to the cloud. So first thing, let's look at word count mapper, just so you can see what that looks like. So this one mirrors the Java approach pretty quickly. And here's a word count function that I've written my map function that I've written. So just to show you that it's encapsulated in that class. Let me come up and now go to word count that deploys to a cloud cluster. So you saw the unit test one. Now let's look what it looks like to deploy to a full-on cluster. In this case, there's a little bit more preamble where you give your authentication information, because we're not running in memory anymore. So your username, your password, et cetera. The storage accounts where your data exists in the cloud. You call hadoop.connect, passing all that information, pretty simple. And then MapReduceJob.execute job. And the key thing is that this word count class is just a container encompassing that same mapper class, that same reducer class. And so from a developer perspective now, you can easily unit test your stuff locally, do it really fast, do it in a test environment that's completely decoupled from your production system, and then when you're ready, you add this preamble and submit the exact same code to the cloud. If you're wondering how we do this submission, et cetera, it's just using the standard Hadoop APIs. In this particular case, WebH catalog for job submission to a cluster that's running remotely. So that's all that's happening in those first few lines. It's abstracting a WebH cat invocation. So let me show you this really quickly. If I actually run this right now, which is going to do the unit testing version, let's get rid of all of this extra stuff. If you were a developer, or if we were debugging this, you'd care. It's got all the locals, et cetera. And so now I'm sitting here in my MapReduce function, and I can step through. I can start to step. Now I'm in my mapper. I can step through, look at everything, make sure it's exactly as I want, and see exactly where my logic might have gone bad. And if you start writing custom MapReduce, you know this stuff can get involved as you start implementing more and more complex algorithms. Obviously, MapReduce is not the most interesting one, and then I just dump the output to the screen. So you can see kind of what a in-memory execution engine looks like for MapReduce. So that's one of the first things that we did. The second thing we did is various languages have different ways of expressing queries. In .NET, there's a thing called LINQ. I don't know if anybody's a .NET developer here, but there's something called LINQ. We wrote LINQ to Hive. What it does is it lets you express queries using the C# way called LINQ. And then just after execution, what we do is we translate that LINQ query to the equivalent Hive query and submit it to the cluster. And so what LINQ lets you do is write stuff that looks like this. DB is just a class that represents the database. Website log is a table within that Hive database. And then you're writing where, group by, select statements, all using classes that you've got in your solution, so the entire query building experience is strongly typed. So it's just a function of an object-oriented language. It's familiar to that type of developer. And so they can use their existing LINQ skills, and under the covers, all of this maps fairly easily to an HQL statement. And if you're a developer, you're going to go, I want to write this, and I also want to compose in custom code. So what we did is we allowed you to write custom functions. In this particular case, I'm querying a website log. Then I'm doing some geocoding using some custom functions I have under the covers here. We're not going to learn the geocode algorithms used, but the idea is that there's a bunch of custom .NET code and a bunch more custom .NET code that's being composed into that Hive query. And so as a developer, you're effectively authoring your UDF, if you will, alongside your Hive query, and then just running it using a lot of the techniques you're used to, in this case, as a .NET developer. If this looks foreign to you and you're not a .NET developer, that's fine. Out the other end, what we end up executing is this, which is just a HiveQL statement. And so this is one of the approaches that we're taking for developers, is trying to make it feel very natural to you, whatever language you run in, and then mapping back to the existing artifacts that have been kind of proven and built out in the Hadoop ecosystem, in this case, Hive. And so when we show this to a .NET developer, they're like, of course, I know how to do that. Big data is not so bad. And then under the covers, we do this work to make sure that we're emitting HQL and everything kind of comes together. And the way that we do this, again, is sitting on top of the standard REST APIs that exist in Hadoop. This translates under the covers with our libraries to an invocation to WebHCatalog with this HQL statement. So it's kind of cool from that perspective, in that you can quickly get up to speed with, and then slowly fault in the new concepts as you want. So let me jump back quickly. Cool. All right, so I talked a little bit about extending to other languages. We've also done some work to extend to JavaScript developers. Originally, we wrote something that let you write MapReduce in JavaScript. I'll be honest, we got mixed results on that one. Some people said, yeah, cool. Other people said, don't really care. And so we gave it a shot. Not sure how much further we'll go with it, but if people are interested, I'd love to hear. It was an experiment we did to see if there was a JavaScript developer community that wanted to be able to write MapReduce. One of the other things we've done recently, though, along the lines of making it really easy to work with clusters, is as we've spun up our cloud platform to make it easy to create clusters on demand when you need them, we wrote kind of a CLI layer over top of that in Node.js. And so if anyone's familiar with Node.js, it's a, I'll say fairly popular JavaScript framework. And so what we did is we wrote a set of commands in Node so that no matter what platform you're on, there's a Node runtime for Mac or Linux or Windows. You can execute these commands, and as a developer, create clusters in the cloud when you need them, when you want to try things out, or if you want to deploy a full-on solution. And so let me show you what that looks like really quick. So if you're familiar with Node, Node has a package manager tool where basically you can say, npm, the name of their package manager, go install this particular Node solution. So what we did is integrate with that. And here, if you could do this today if you wanted to, if you had Node.js on your whatever machine you've got. You could run npm install -g from our GitHub account. You could go grab our Windows Azure SDK tools. If you run this one command line in Node, what you'll end up with is the ability to do something like this. If I'm still connected, you'll be able to say Azure, that's just the name of our cloud platform, HD Insight, the name of our Hadoop service. If I can type, I'll hit enter. This lists all the commands that are available to you. one command that I can run, sorry, I've noticed we've got a little bit of screen cut off here. One command I can run is say Azure HD Insight cluster list, I think it is. And what it's doing is it's contacting my account that I've already fed my password in as a config file, so I didn't have to show all of you it. But what it's doing is it went and contacted our Hadoop service in the cloud, and it asked the service, how many clusters does Mike currently have deployed, and what are their names? You can see I currently have 3 Hadoop clusters deployed, attached to me, all of them in the East US region. Today, with this, you can deploy clusters in the United States, in Europe, soon to be Asia, et cetera, from the command line. And so the first thing was to list all of the clusters. And now as a developer, if I want to get a new cluster so that I can start, whatever task it is, it looks something like this. So I tried to do a nice formatting of it here so that we could look at it. And the idea is that with one command, you can spin yourself up a cluster of whatever size in whatever geographic location you want and bind it to one of our storage accounts, which you can think of as a big disk in the sky that you can pump any data of any shape that you want into. And so the idea is that with this command, I can spin a cluster. And so I've got the not formatted version of this, so I can cut and paste. You can also see my password, so just don't tell anybody. And if I go here, let's do, yeah, this will be fine. All right. And so at this point, what it's doing is it's actually going and creating a cluster with these parameters in our cloud. It takes about 15 minutes to fulfill this request. And that request is for something up to about 4 nodes. You can go to about 40 nodes in 15 minutes. Let me grab one other file to show you. I think it's kind of interesting. I thought I had it open already. I apologize for not. This guy. Is it open? There we go. So what I showed you is that command line to create clusters. The other thing that you can do is you can create config files that are just JSON documents. And then you can script these with node.js and say, create a cluster based on this cluster description. And so if you really want to get fancy with a cluster in terms of really configuring it however you want, you can externalize your metastores, you can provide a custom Uzi metastore, et cetera, that's encoded in this JSON document. Yeah?
Are the JSON specifications you have there something you invented, or you're taking advantage of an existing REST API?
I apologize. I missed the first part of the question.
What you have there, those JSON specifications,
Yeah, this? Yeah.
are they something that you guys invented, or are you taking advantage of an existing REST API?
Got it. What's happening here is this JSON document is just the parameters that we need to create a cluster in the cloud. So there's no kind of standard schema behind this or anything like that. It's just a JSON document with these properties. And then the submission endpoint for cluster creation, or the REST API for cluster creation, is one that we expose off of our cloud platform. It's a REST API. It takes something like this as its input, creates a cluster for you. There's no standard API for that, I guess. Okay.
Is that something you're working with the Mbari team with as well?
Yeah, absolutely, absolutely. And so for cluster creation, it's a custom one. As soon as you've created a cluster, we expose the Mbari API to you. And so if you want to monitor that cluster, see what's going on, the Mbari API is exposed to you. Yeah.
Thank you. That's great.
Thanks for the question. All right, so that was the JavaScript experience. Again, the goal there was to make it really simple, no matter where you are, to get a cluster up and running. One command line, 15 minutes later, you're partying kind of at scale on a cluster. Last bit, it kind of leads in from what we were just talking about, but going into management, we've talked about cluster creation, but you also need a simple way to do job submission. So you can complete the whole loop, create cluster, submit remote job, tear down cluster, monitor cluster, et cetera. And so the thing we've been doing there is, to the question the gentleman asked a second ago, We expose Embari directly for management, et cetera. But then we've also been scripting job creation as well, so that if you want to submit jobs and monitor the process of those jobs, you can do them from the command line as well. If you're a Node.js person, we'll continue to do it in Node.js. If you're a traditional Windows IT guy or DevOps guy, you'd be using something called PowerShell. That's our kind of equivalent of Bash, I guess, in Linux. And so what I thought I'd show you, just to kind of round out a tour of different things for different developers, was now remote job submission scripted using PowerShell. We could do the equivalent thing in Node if you wanted. And so if you're a Windows guy, you're used to stuff that looks kind of like this in PowerShell. And so what it is it's a script file that from a command line in Windows, you can execute these high-level functions. So what we did is write scenario-specific functions so that from the command line, you can script a solution. You could script cluster creation, you could script job submissions, Uzi workflow execution, and then cluster teardown. The idea being you can then get these Hadoop clusters when you need them, take them down when you don't need them, and only pay for what you're using. And so command line in that regard that we've been working on, this is a newer thing for us. So it's not the prettiest one yet, but a bit newer for us. Let me find it down here. Cluster config, PowerShell. So if I pick up this particular query and run it, what this is going to do is it's going to say, start this Hive query against this cluster and put the result here. And so you can think about composing this to something that is create cluster, execute workflow, tear down cluster. But I'll just show you the job submission one really quickly. This is just a kind of a debugger experience for scripts in Windows. So let me write this guy here, start executing. So what this guy did is just kick off this Hive query. I already had some tables created in my cluster. Great. Now I have a job ID that came back from the cluster. This, I think, was what web hcat call. And let me go back to where we just were and put this guy here. Get rid of this one. And then here I want to go and ask questions about the job so I can monitor its progress. You might do this from a dashboard or something as a developer. And so if I go back and execute this and say, tell me what's going on with that job that I just ran, what it came back with, let me make this bigger so you guys can see, was a JSON document that has a status property, a profile property, an ID property. And this is just a JSON document that's kind of a full description of what's happening with that particular job. So as a developer, you can script, you can get back the results and understand what's going on, kind of build something out. So this is a start of some of these building blocks we're trying to make available to developers. So it's very easy to get going. They can combine them together in whatever interesting ways they want to kind of build out full solutions. The idea is trying to be not too invasive so that you spend all this time learning some other framework. The idea is meant to really make scenario-based, very thin clients over top of a lot of the Hadoop APIs that already exist. So as a developer, you can get your work done, but you don't learn about Hadoop, learn about some other platform, SDK, something, 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 and then get going. The idea is learn about Hadoop and then provide you very simple tools that built on top of them so you can get going. At least that's the kind of our thinking so far. As I said, one of our goals in doing this talk was to kind of talk about some of the things we were doing, some of the challenges we've been hearing from Hadoop developers, and then ideally kind of continue this discussion with everybody in terms of what are other things we could do, whether they're .NET, JavaScript, Java, tooling, et cetera, that kind of make the whole ecosystem move forward, at least from a development perspective. Because for us, we feel like the more that moves forward, the better we all are in terms of we've all got more customers that are joining the Hadoop ecosystem, the whole thing's moving forward. And so with that, I wanted to just leave you with a resources slide that lists a lot of the things I used today. If you go to hadoopsdk.codeplex.com, you can look at pretty much the source of everything that I showed today, from the Node.js stuff to the .NET stuff, et cetera. If it's not there, it should be there. Just tweet me and I'll put it there. But I think the little red light is showing up in front of me now, so I think I have about 57 seconds. So with that, I just wanted to thank everybody for their time. I really appreciate you coming to the session. I'd love to hear kind of what people want to do with development tools in Hadoop. Thank you for your time. Happy to take questions. I'll stick around if anybody has any questions. Okay. Yeah. Sure. Okay. Great. Thanks. So I got to clear out of here, so I'll just hang out at the back if anybody wants to jam on Hadoop tools.